Hi everyone, welcome back to the channel Code with AKJ. Today is day 50 of solving GeeksforGeeks problem of the day, and today's question is swap and maximize. So the question says here, given an array ARR of positive elements, consider the array as circular array, meaning the element after the last element is the first element of the array. The task is to find the maximum sum of the absolute differences between consecutive elements with shuffling of array elements allowed, that is, shuffle the array elements and make a of 1 with a of n such that a1, a2, a2, a3, the difference between them should be maximized. So given an array ARR of positive integers, we need to arrange its elements in such a way that it maximizes the sum of absolute differences between consecutive elements. So since this is a circular array, we also consider the absolute difference between the last and first elements. So given example here, array 4, 2, 1, 8. We need to arrange this particular array in such a way that the absolute differences between consecutive elements and their sum should be maximized. So here for this particular array, the possible and perfect shuffling would be 1, 8, 2, 4, where the sum of absolute differences would be maximized. Here you can see the consecutive difference between these two elements are 1, 8, 8, 2, 2, 4 and 4, 1, which gives us 7 plus 6 plus 2 plus 3, which is finally 18. And same goes with the second array, 10 and 12. So here, since there's no need of arrangement, since we have only two elements in this given array, so the sum of absolute difference between these two would be 4. So here the goal is to arrange elements in an array to maximize the sum of the absolute difference between consecutive elements. So initially our brute force approach would be we would try all the possible permutations of this given array and compute the sum of absolute difference of each permutation. And then we finally choose the permutation that yields the highest sum. So let's analyze with this given example 4 to 1, 8. So let's analyze our brute force approach through this particular example. Here I have taken an array 4 to 1, 8. So in our brute force method, we'll try each and every permutation of this given array, and then we'll try to calculate the absolute difference sum, and we'll consider that particular permutation which gives us highest sum. So considering all the permutation of this given array, the size of the array is 4, so the number of possible permutation would be n factorial, which is 24. So I have written few permutations here. So let's calculate the sum of consecutive elements and their absolute differences. So for the first permutation, the absolute difference would be 4 minus 2, 2 minus 8, 8 minus 1, and 1 minus 4, which gives us 2 plus 6 plus 7 plus 3, which gives us 18. So here we'll take a sum variable which will store our maximum sum value. So initially our sum is 18. So let's try with another permutation. Same goes with 4 minus 1 and 1 minus 2 and 2 minus 8 and 8 minus 4, which gives us 3 plus 1 plus 6 plus 4, which is 14. So sum remains 18 as we need to take the maximum sum. And finally, move on to the third permutation. The sum of absolute difference of consecutive elements here would be 1 minus 8, 8 minus 2, 2 minus 4, and 4 minus 1, which gives us 7, 6, 2, and 3. So total would be 18. So as we go on with further permutation, we'll find out that 18 would be our maximum sum. So in this case, we'll return answer as 18. So let's move on to the code. So this is a code for the brute force approach we have discussed. Here I have taken max sum variable, which would be initially 0. I have used do while loop to consider each and every permutation. I have used next permutation C++ inbuilt function where it will generate each and every possible permutation of the provided array here, which is ARR. I have taken some variable which will calculate the maximum sum of consecutive elements absolute differences. I have used a for loop which will iterate over this given array, and this particular condition is for the circular array where we'll take the absolute difference between the last element and the first element of the given array, as we need to maintain the circular property, and I've calculated the sum variable by taking the absolute difference between these two elements, array of I and array of j. And for each particular permutation sum calculation, I have updated the maximum variable. And finally, I have returned that maximum variable. So let's compile and run this. It's working, so let's submit. As you can see, this approach gives time limit exceeded, as the time complexity of this approach is O of n factorial, where we are trying to generate each and every permutation of this given array, and space complexity here is O of 1, which is optimized. So this approach, as expected, is highly inefficient for larger arrays. So we need to optimize this approach in terms of time complexity. So let's now discuss a more efficient method that avoids checking all these permutations. So to maximize the sum of absolute difference, one thing we can do here is to arrange elements in an alternating pattern of smallest and largest values. So this can be observed by this given example 4218. Here after shuffling we get 1824. So if we try to observe this particular shuffled array, we can easily see that the first element is smallest and second element is largest, and third element is second smallest and fourth element is second largest. So we need to arrange elements of this array in such a way that the first element should be smallest and second element should be largest. So the alternating way. So the strategy here would be to sort the array in ascending order and then take elements from the start and end of the sorted array alternatively to form a new array. So this way we place the smallest value next to the largest value to get our maximum differences. And finally, we'll calculate the sum of absolute difference in this reordered array. So let's understand this approach with this example 4218. So our first step here would be to sort this given array, which gives us 1 2 4 8, and we'll create a new array where we try to take elements from start of this array and from ending of this array. So we'll create a new array by picking elements from the start and end of this given array. So initially from the start, and then we'll take the end of element. We'll take then again from the starting of this array, and finally from the end of this array. So in this way we'll create a new array 1824, and now we'll calculate the absolute difference between these consecutive elements, which will give us 1 minus 8, 8 minus 2, 2 minus 4, and 4 minus 1, which gives us 7, 6 plus 2 plus 3, and finally gives us 18 as an answer. So here the time complexity would be O of n log n, as we are sorting the array, and space complexity would be O of n. So this is much more efficient than the brute force approach, where the time complexity is O of n factorial, which is worst, and it won't be working for the larger arrays. So here in terms of time complexity we have optimized way further. So this is a code for the optimized approach we have discussed, where our step 1 would be to sort this given array, where I have used the sort function to sort this given array. I have taken a new vector, new array, where we'll try to push all those elements from this given array in an alternative pattern. Here our step 2 would be to reorder to maximize our absolute differences, where we'll take the smallest element first and then largest element. So in case if the size of an array is odd, we'll try to take the middle element here. And final step here would be to calculate the sum of absolute difference, where we'll try to maintain our circular property by taking a modularity with the size of the array. And finally we'll calculate the sum of the consecutive elements, and we'll finally return that particular sum. So here the time complexity would be O of n log n, as we are using sort function, and space complexity would be O of n, as we are trying to create a new array out of it. So let's compile and run this. So let's submit. As you can see, this problem got solved successfully. So that's it guys. The optimal approach gives us the maximum sum of absolute difference in just O of n log n time, which is efficient enough for larger inputs. So if you found this explanation helpful, please like the video and subscribe for more coding solutions explained step by step. Also don't forget to hit that bell icon for updates on daily coding challenges. So Happy coding and see you in the next video.